Hi guys, good afternoon. I wanted to thank you for watching the video. Tonight's homework is to be completing a foldable. Okay, the foldable is going to be quite easy. It's going to look in the very end, it's going to look something like this. Okay, you're going to be able to fold it in the middle again, and then you have like a little accordion. Okay, so we're going to have information on the front and on the back. You do need the handout. If you didn't get the handout today, you need to get it tomorrow and watch the video tomorrow, because without the handout you're gonna have a hard time. Okay, so you should have the handout in these little squares. I know that not all the classes got it, so I'm going to only concentrate on this part, and then tomorrow when you get the second part, you can weave it in. Okay, first thing I'd like you guys to do is go ahead and fold your paper in. Well, go ahead and fold it in half. That's probably easiest. You can fold it in half. And then once you fold it in half, you're going to take that half and fold that into the half, if you will. So you're going to fold it into 1/4. And the way that I like to use the middle to help guide me, okay, so that I know that it's as even as I can of a fold. So on the outside, you're going to have the square root. On the inside, you have domain, range, and then transformations. Okay, so on the front, this is where we're going to fill out in the front. We're starting a new unit. We are in a new 9 weeks, so we get to start fresh, which is exciting. I want you guys to go ahead and follow my lead. Okay, what we're going to be talking about this week is about square root functions. So you're going to go ahead and write the word square root. Okay, sorry, the square root function. This symbol right here, which we know as a square root, okay, is also called a radical. So because it is a radical function, it has a radical sign, and it's also known as square root. The parent function is always the square root of x. Okay, I'd like to put a little hinge on the function so that you know that that's where the square root ends, and then we're going to have some functions or some transformations added to the end of this function. When you graph this function, I need you guys to go use your book or phone or whatever. You're going to go to, or I'm sorry, I meant computer. You're going to use your computer or your cell phone to go to Desmos graphing calculators. I had already shown you guys how to do this at home. If you're doing this inside the classroom, you can do it with TI Inspire. You're going to go to the Desmos website, and in the Desmos website, you're going to put the square root of x. I'm not sure why it's taking so long. Okay, there we go. So when you graph the square root of x, there we go. You're going to select the square root of x, and it graphs it for you. So this is what the square root of x function looks like. You want to see the table, you click on convert to table, and it shows you some values. Okay, some of the important points are 0, 0, 1, 1, and then that looks like 2 1/2. Okay, so back to your paper. You're going to go ahead and plot the point 0, 0, and then what was it, 1, 1. And then let's do 4, 2. So when you connect these dots, your graph continues to go to the right forever. Okay, does it have any intercepts? It does. It has the x-intercept and the y-intercept at the same place. So the intercepts are at 0, 0. This is considered to be a minimum. It is the lowest point on the graph, so the vertex occurs at 0, 0. The domain of this function is where does your graph start on the x-axis? It starts at 0 and goes forever to the right. So x is all the values greater than or equal to 0. So the domain is all x values greater than or equal to 0. Your range is what are the possible output values. And if you look at your function, at your graph starts at 0, 0. So y, does it go up or does the function go down? Well, the function goes up, so y, or the range, are going to be greater than or equal to 0. Your verbal description, how would you describe this function, the square root function? Some students in class today said that it was a curved line. That's right, it's not straight. It definitely does curve and it continues to go forever to the right. If I go back to my graph, you can see that even if I zoom out, the graph keeps going and going and going up and up and up and forever to the right as well. So if I zoom out, you can see that the graph is continuously moving to the right. Okay? An interesting thing about this function is, doesn't it look like half of a parabola? Doesn't it kind of look like a quadratic function? If I were to draw the same thing, if I were to reflect that on the other side, it would look like a parabola. So it is also half of a parabola. One of the special properties of the square root function is that it is the inverse of the quadratic function. So it undoes what the x squared does. So if I were to solve for the inverse, I would have to replace f of x with y. In order to solve for the inverse, I would have to switch x and y. And then you have to solve for y. I need to get rid of this square root. So I'm going to take the square root of both sides. The squared, I keep saying square root, sorry. So x squared is equal to, the squared and the square root cancel. So the inverse of the square root function is actually x squared. Okay, so if you have the square root of x, its inverse is x squared. I did a little visual. This is a square plus, what are these things called on the bottom? That's right, square roots. Okay, just a little simple way for you to remember about square root functions. So this is what we're focused on this week. We learned a lot about quadratics. Now we're going to learn about square roots. If you open the inside sleeve, it should say domain. So go ahead and change that. And they had arrows going to the left and right, and then the x values. Okay, so the possible input x values. This is some special properties. Okay, so if you look down here at the square root function, it kind of looks like a quadratic formula in standard form, right? We have an a, b, an h, and a k. The only thing that changed is that instead of parentheses and an x squared, we have a square root. Okay, so if it's in this form and b, so if b is greater than 0, then your vertex is hk. Okay, your vertex is always going to be hk. So let's look at this first thing. If b is greater than 0, then that means that b is a positive number. If b is a positive number, then that means that the domain is going to be all the values greater than or equal to h. Okay, and in this case, I put negative h just to show that it's the opposite of whatever h is. So instead, I'm just going to write it in here because I think writing a negative would confuse you. So this is the opposite of h in the equation. Okay, if b is less than 0, if b is a negative number, This is where it gets a little bit tricky. If b is less than 0, then the domain is going to be less than or equal to h. So it's actually going to be the same as the equation. So if you see in your equation a positive h, then it's going to be a positive h. If b is greater than 0 and you see positive h, is actually going to be negative h. This may not make a lot of sense right now, but it will soon, okay? The last thing is if a is greater than 0, I'm sorry, greater than 1, this is a typo, this should say 0. So if a is greater than 1, or if a is positive, then the range is going to be y is greater than or equal to k. Okay, if a is less than 0, then the range is going to be y is less than or equal to k. Okay, so let's look at some examples. If you look at this first graph, your function is pointing in this direction. Is your domain positive or negative? That's right, it is positive. Is your range positive or negative? The range is also positive. It's pointing up and going to the right. If you look at the next example, is your domain, your function is pointing to the left. Whenever we go left on the domain, on our x values, they're negative, and we're going up, so our range is going to be positive. Okay, if you look at the bottom half, this side is moving to the right or to the left. Well, our graph is moving to the right, so it's a positive domain. But instead of going up, like the other examples, it's actually going down. So your range is going to be negative. Okay, if you look at this next example, if the domain is it moving to the right or to the left, it's actually going to the left, which is negative x values. And your range or your y values are also going to be negative. So it's pointing to the left and it's pointing down. Now let's see what that looks like in a real function, in an actual function. Okay, if I write negative square root of x plus 2 plus negative the square root of x plus 2 plus 4. I'm going to graph that function into my calculator, and I'm going to use the Desmo since I know that's what you guys have at home. Okay, so you're going to write negative or minus, in this case, square root of x plus 2, and you have to move out of the square root symbol and put plus 4. Notice how the plus 4 is outside of the square root, and hopefully I can make this a little bit smaller so that you can see the whole graph. Okay, I'm going to erase the original. If you notice from the original, it was flipped over because of the negative a. It was shifted 2 units to the left, and it was shifted up 4 units. Okay, so this is my new function. I'm going to put these points. I'm going to pick only the whole numbers. So in our table, I'm going to put x and y. So our whole numbers occurred at negative 2, negative 1, and positive 2. If I look at my table, when my input is negative 2, my output is 4. When my input is negative 1, my output is 3, and so on. So we have negative 2, 4, negative 1, 3, and 2, 2. So I plot my points. You guys should be able to do this on your own. Okay, this is when you plot your points. You're going to connect the dots, and you have your vertex. Where does your vertex occur? Your vertex occurs at HK, and we know that H is always the opposite, so it's going to be at positive 2, positive 4. I'm sorry, the opposite, which instead of a positive 2 is going to be a negative 2. So your vertex is negative 2, positive 4. Your domain is all the x values that are greater than or equal to negative 2. It starts at negative 2 and it moves forever to the right. Your range it starts at 4, right? And is it